And hello. Today we'll be looking at equation fundamentals. So you should already be comfortable with expressions and manipulating algebra. And now we'll be looking at exactly what an equation is. We won't be trying to solve equations just yet. We'll literally just be discussing what exactly an equation is and how do we treat equations in mathematics. So I'm going to start off by using a real world analogy that we can then derive what an equation actually is. And that analogy is a weighing scales. So imagine you have these weighing scales. So you have one on this side and one on this side. Now let's say I added 3 apples onto the left hand side. Now in your mind's eye, well, what would happen? Would this scale go down, or would it go up, or would this go down, or would this go up? Well, think about it. This side would go down. Now, why would it go down? This side is heavier than this side. So, because there's 3 things here, there's nothing over here, so it would go down. So this scale wouldn't be balanced. If the scales is the exact same height and it's just not moving up or it's not moving down, that's what we call a balanced scale. So in this example, we have 3 apples on the left hand side, 3 apples on the right hand side. So it is balanced because the same weight is over on this side and the same weight is over on this side. So everything is equal. So it's not going to, this side is not going to move down, this side is not going to move up, or it's not going to move at all. It's going to stay still. Let's say you had this example. So I have 2 apples on this side and I have 5 apples on this side. Well, what's going to happen? Well, it's going to move up. Yeah? This side is going to move up. This side is going to move down because this side is heavier. So how are we going to balance it? Well, what we can do is we can take away 3 apples. Yeah? Because then we'd have 2 apples on each side. So it would remain the same. Or we could have added 3 apples onto this side. So remember there was 5 apples over here. If we added another 3 apples on this side, then it would be balanced. So as long as you have the left hand side and the right hand side are exactly the same, we're balanced. Here's kind of a stranger example. I have 2 apples here, and then I have a block. Now this is balanced starting off. So I'm saying that 2 apples weigh the exact same amount as this little block over here. So it's balanced. What happens if I added 2 apples to this side? Now, what's going to happen? It's going to go down because this side is heavier than this side. So it's going to go down and this side is going to go up. Now, how would I balance this? Well, think about it. What would I have to add? Well, if I added 2 apples to the block, well, the block weighs the same as 2 apples. So there's 2 apples is 1 block, and then I had another 2 apples and another 2 apples. Well, now it's balanced. I also could have just added another block. So remember, 2 apples is exactly the same as 1 block. They weigh the same. So I could have added a new block, or I could just add 2 apples. So if I do one thing to the left hand side, I can do it to the right hand side. Okay, let's say we're back balanced again. So 2 apples is the same as a block. Now I've added another 4 apples. Well, what will I do now? Well, obviously, I could add another 4 apples over here. That would make it balanced. Or another way of thinking about it, I multiplied this side by 3 because they started off with 2 apples and I now have 6 apples. So I just said 2 times 3. That's how many apples are here. So I multiplied this side by 3. Well, if I did to this side, I can do the exact same to the other side. So think about it. 2 apples is the same as 1 block. So there's 2, 4, 6 apples of weight in these blocks. And there's 6 apples over here. So all I had to do is, if I multiplied this side by 3, I can multiply this side by 3. And then they're balanced again. So why am I talking all about weighing scales? Well, this is the important note to keep balance. Whatever you do to one side of the scale, you must do the same on the other side of the scale to remain balanced. So in the previous example, when this started off as balanced, If I added 4 apples, or I multiplied it by 3, I have to do the exact same to this side to make it balanced. So whatever I do to one side, I do have to do to the other side. Let's say I had 3 blocks on this side and only 2 apples over here. Well, then I'd have to add another 4 apples or multiply this side by 3. So whatever you do to one side, you have to do it to the other side to make it balanced. And this is the really important part to remember for when we talk about equations, and I'll show you why. So an equation is just a mathematical way of representing a balanced scale. And we use the equal sign, so it's like 2 little parallel lines, to represent a balanced scale. So, what do we mean? 7 is equal to 7. So this is kind of saying, oh, there's 7 apples on this side and there's 7 apples on this side. And it's balanced. These left-hand side is equal to the right-hand side. If this was on a weighing scales, there were 7 apples over here, there's 7 apples over here. They're not, one side's not going to drop, one side's not going to lift. It's exactly balanced. What about this? If I added 3 to both sides, is it still balanced? Well, yeah, it is, because think about it. This is like, oh, I had 7 apples, I added another 3. 7 apples, I added another 3. We're on 10 apples each side. It's balanced. And this goes back to whatever we do to one side, we have to do to the other side. So I've added 3 to the left bit. I've added 3 to the right hand side. So then it's still balanced. What about this? 7 minus 2 is equal to 7 plus 4. Is that correct? Well, no. Think about it. 7 minus 2, that's going to be 5. What about 7 plus 4? That's 8, 9, 10, 11. So is 5 equal to 11? If I have 5 apples on one side, is that equal to 11 apples? No, that's not. It's not balanced. It's going to, if this was the weighing scales, which an equation actually just isn't, it's supposed to be a balanced weighing scales. It's not balanced. It's not an equation. What about this? 7 minus 2, 7 minus 2. Well, it obviously is, because I've done the same thing to both sides. I had 7 apples, I take away 2. I had 7 apples, I take away 2. Left hand side of the scale is exactly the same as the right hand side. Okay, what about this? We'll talk about minus numbers, and you might be thinking, oh, well, what does this mean? Well, it's the exact same thing. Imagine you had minus 3 apples, which might be a little bit confusing, but it's still just a number. And it is balanced because there's minus 3 apples over here and there's minus 3 apples over here. Well, what about this? I had minus 3 plus 1 is equal to minus 3 minus 5. Now, this is a bit different. You'll notice, okay, this side is 3 minus 5. This is minus 3 plus 1. Now we have to be a little bit more cautious. They don't look originally like this, but is it still balanced? So what's minus 3 plus 1? Well, that's minus 2. So I have minus 2 on the left-hand side. Now I have 3 minus 5. What's that? Well, that's also minus 2. So on the left-hand side, I now have minus 2 apples, and on the right-hand side, I have minus 2 apples. Well, think about it. Is it going to fall? Is it going to rise? Well, it'll be exactly the same. So it is balanced. What about this one? 5 minus 2. Okay, so that's going to be what? That's going to be 3. And 2 plus 1. Well, that's going to be 3. Both sides are the same. So yeah, that's also balanced. If I had 3 blocks on one side, 3 blocks on another side. Okay, 7 minus 2 and 12 minus 5. Well, no, that's an obvious one because 7 minus 2 is 5. 12 minus 5 is 7. So there are obviously different numbers on each side of the weighing scales or the equal sign. So it's not equal. So just a little note from algebra, because we're going to be talking now about equations with algebra. You can only add and subtract constants with constants and variables with variables. Now I forgot to add variables of the same type. So if I had x plus x, I can say that's 2x. If I had y plus y, that's 2y. But I can't add x plus y. That doesn't make any sense. So it's just going to be x plus y. So here's an equation. It starts off balanced. Yeah. So this is there. You're given this. It's balanced. Somebody has said, look, here's a weighing scale. this left-hand side is exactly the same as the right-hand side. So minus 3 is equal to x plus 1. Now, remembering the rule of when we were working with scales, if I do something to one side, I have to do it to the other side. And if I do, then it's still balanced. It's still going to be the same. So, is this balanced? Looking at the original equation up here, is this balanced? Well, yeah, it is. Because look, I added 1. So I had minus 3 on the left-hand side. What changed? I added plus 1. And on this side, well, I also added 1. So yeah, it is balanced. Think again of your apples. I just added one apple onto one side of the scale. I added an apple to the other side of the scale. It's not going to be imbalanced. It's going to stay the same. Now, a little bit trickier. Minus 3 and I multiplied it by 2, and I have x plus 1 and I multiplied it by 2. Is that going to be balanced? So going back to the multiplication balancing scale example that I used, think about that. Will it be balanced? Well, I multiplied this whole left-hand side, everything here, so everything on the left-hand side by 2. And then x plus 1, so everything on the right-hand side, I multiplied it by 2. So yeah, it is balanced. What about this? Minus 3 plus 4 is equal to x plus 1 minus 5. Well, what did I do? I added 4 on this side. So what's the difference between minus 3 and here? Well, I added 4. What's the difference between this side and this side? Well, I subtracted 5. So did I do the same thing on the left-hand side and the right-hand side? No. So this would be an imbalance, and this is no longer an equation. This does not work. So if I started out with this, I can't suddenly get down to here. That doesn't make sense. I can't do this. I just throwing in random numbers and it's no longer balanced. It's not an equation. Last one. What if I had minus 3 plus x is equal to x plus 1 plus x? A bit trickier now. Now, I know what you're thinking. Well, what about the x's? It's a variable, it's not a number, it's not a constant. How are we going to do this? Same rules apply. What did I do to this side? I added x. So I was minus 3 starting off, I added x. This side, what did I do? I added x, so it was x plus 1, but I added another x. So is it an equation? Still, is it balanced? Yes, still balanced. The weighing scales, I just added x of something onto x on the left hand side, and I've added x of something onto the right hand side. So it's still balanced. So this is the really important thing to remember with equations for when we start manipulating them. Whatever I do to one side of the equation, I have to do to the right hand side. And in particular, just be careful with this multiply one. So you multiply everything on this side by a number. You have to multiply everything on this side by the same number. You can't just say, oh, I multiply x by 2. You have to do the whole side and the whole side over here as well. Okay, so here is some recap questions, so you can try them out. Alright, which of these equations below are correct to state? So I started off with 4x plus 7 is equal to 5. So what happened? Well, first equation, I added x, because look, it was 5x plus 7. What was the original one? Well, it was 4x plus 7, so I added another x. And then on this side, it was 5. Well, now it's 6, so I've added 1. So I added x on the left-hand side, I added 1 on the right-hand side. Is it balanced? No. Next one. It was 4x plus 3. Well, it was 7 here, and now it's become a 3, so I've subtracted 4. And then on this side, I've subtracted 2, because it was 5, and now it's 3. Subtract 4, subtract 2, it's not the same, it's not balanced. So that means, obviously, the last one has to be balanced. 3x plus 7 is equal to 5 minus x. I've subtracted x from this side, I've subtracted x from this side, so it's going to be the same. Okay, by subtracting 17 from both sides, I have x plus 17 minus 17 is equal to 36 minus 17. This is completely fine. Still balanced. Whatever I've done to the left-hand side, I've done to the right-hand side. Okay, well, what's plus 17 minus 17? Well, that's going to be 0. So I have just x left over here. And then I have 36 minus 17. So what's that? Well, x is equal to 19. And we'll look at that in further lessons for solving equations.